Hey everyone, and welcome to This Explainer. Today, we're dissecting an absolutely huge transformation happening right now in artificial intelligence. We're moving way beyond the era of just, feeding massive amounts of raw knowledge into a machine and crossing our fingers. Instead, we're looking at a highly deliberate process, the evolution from basic raw knowledge into incredibly sharp, specialized AI. The blueprint for this transformation comes directly from Codatta. They're a specialized data platform and framework designed specifically to build these expert systems. We're going to unpack the exact technical mechanics of how you take a totally blank slate model and literally engineer it into a rock-solid enterprise tool.
Okay, let's dive into this. To really appreciate what the Codatta framework is pulling off here, we kind of have to look at the baseline problem we're solving. We have a really distinct contrast. On one side, you have general models. These are your jacks of all trades. They have a massive, sweeping understanding of language and patterns, but honestly, their knowledge is broad and flat. A general model can summarize a casual email perfectly, sure, but it will confidently fail at parsing a complex 400-page legal contract or diagnosing a rare cardiovascular disease. Then, in stark contrast, you have specialized AI. This is a system designed to master one single domain flawlessly. So, the core challenge in AI right now is how do you cross that chasm? How do you take a generalist and actually mold it into a master specialist? The answer, the absolute key catalyst in this whole reaction, is domain knowledge. A general model cannot simply guess its way into becoming an expert. It requires highly specific inputs to kickstart the transformation. It's essentially the forge that makes this all possible. And domain knowledge isn't just some generic pile of internet text either. In practice, this means feeding the model proprietary datasets, expert human feedback, and highly curated industry textbooks that are usually locked away behind paywalls or inside corporate knowledge bases. This specialized data is the secret ingredient. Without it, you basically just have a very articulate but ultimately generic system. With it? Well, that's when you begin the targeted process of building a true specialist.
Now, what's really interesting about this slide is that Codatta doesn't just throw domain knowledge at the wall to see what sticks. They deploy a rigorous four-pillar framework to guarantee this transformation. You've got this sequential roadmap right here: teaching, guiding, grounding, and testing. It is a highly methodical process. Each of these four steps is an absolutely crucial mechanism. If you skip even one of them, the entire specialist model just falls apart. It's not magic, it's an engineering pipeline. So let's break down exactly how each of these technical phases works to physically reshape the AI from a broad conversationalist into a precision instrument.
So, step one is teaching. Let's focus on this very first active strike of the hammer. You aren't just pouring data into a bucket here. You're actively instructing the general model using pure, highly curated domain knowledge. You're laying down the foundational vocabulary, the core principles, and the absolute truths of that specific field. To put that into perspective, practically, this means feeding the AI thousands of expertly annotated medical scans or the strict syntax rules for a proprietary coding language. Because before the AI can execute complex tasks or solve niche problems, it first has to be taught the underlying architecture of the domain. This step sets the stage. It gives the model the specific intellectual raw materials it needs to even begin acting like a specialist.
But teaching alone just isn't enough, which brings us to step 2, guiding. Once the model actually has the knowledge, it needs to know how to use it. Look, a model might know all the facts about a subject, but if it applies them in the wrong context or uses flawed logic, it's totally useless. Guiding physically shapes the model's trajectory by establishing strict constraints and guardrails. In data science, this is often achieved through techniques like reinforcement learning from human feedback, or RLHF, along with really tight prompt constraints. This step ensures that as the AI begins to process inputs and generate outputs, it stays strictly on its newly specialized path. It's all about instilling the correct methodologies and the exact ways of thinking that human experts rely on every single day.
And this brilliantly illustrates our third crucial pillar, grounding. Because even a perfectly guided model can drift. And in the world of AI, an ungrounded model is a dangerous model. It might hallucinate, making up facts that sound completely plausible, but are entirely fabricated. Grounding fixes this by anchoring the model's outputs directly to verifiable reality. In the Codatta framework, this often means integrating techniques like retrieval augmented generation, or RAG. This literally forces the model to pull its answers directly from a verified database of strict domain truths, rather than just relying on its own statistical memory. By grounding the AI, you ensure that every single answer and every analysis is firmly rooted in fact, which builds that absolute trust and reliability you need in a specialist.
Finally, we reach the fourth pillar, testing. You can teach, guide, and ground all you want, but until you put the system under real pressure, you don't have a specialist, you have a hypothesis. Testing is the final, rigorous validation step. And we're not just asking it a few tricky questions here. This involves intense adversarial red teaming, where engineers actively try to break the model or trick it into making mistakes. It also involves blind grading, where human experts evaluate the AI's outputs against human-generated work to ensure complete accuracy. This testing phase ultimately proves that the AI can handle really complex edge cases, that its grounding holds up under intense scrutiny, and that the general model has officially transformed into a true specialist, completely ready for deployment.
So the whole thing really comes together perfectly in Codatta's core mission, forging specialist AI through domain knowledge. This is not some passive evolution. By running general models through this deliberate pipeline of teaching, guiding, grounding, and testing with pure domain knowledge, Codatta is actively engineering an entirely new tier of intelligence. They're taking raw compute power, blending it with the boundless potential of general knowledge, and processing the whole shebang into a highly specialized, deployable enterprise tool. Which leaves us with this final, massive implication to consider. We've seen the mechanics of the transformation, right? But what actually happens to our most complex industries when these general models are fully grounded, rigorously tested, and successfully engineered into absolute specialists? Think about it. If domain knowledge can turn a broad tool into a master craftsman through these 4 steps, what happens to fields like accelerated drug discovery or high-frequency algorithmic trading? What boundaries of innovation are we about to shatter next? It's a completely fascinating question, and one we are for sure going to see answered very soon. Thank you so much for joining me for this explainer. Keep questioning and keep learning.